There is a photograph of Pluto that most people have seen at least once. It shows a rust-red world with a giant pale heart blazing across its surface, a swirling nitrogen glacier framed by jagged mountains of solid water ice, catching the last faint warmth of a sun that from Pluto appears as little more than a brilliant star in a black sky. It is one of the most beautiful images ever captured by a spacecraft. And here is the quiet, almost uncomfortable truth about it. It may be the best image of Pluto that any human being will ever see. Not the best so far. Quite possibly the best ever, because right now, as you watch this, there is no spacecraft heading back to Pluto, no mission on the drawing board that will arrive there in the next several decades. NO plans to follow up on one of the most astonishing close-up encounters in the history of space exploration. We looked, we marveled, we moved on, and now the question lingers in the dark, like Pluto itself, cold and unresolved at the edge of the solar system. Was that really it? To understand why those images are so precious, you have to understand how difficult they were to obtain in the first place. The story of the New Horizons spacecraft is not just a story of engineering triumph. It is a story of near misses and canceled budgets and stubborn years-long advocacy from scientists who refuse to let one of the most fascinating worlds in our solar system remain a permanent blur. From 1990 to 2006, a span of 16 years, NASA proposed, canceled, redesigned, and nearly abandoned a mission to Pluto no fewer than 6 times. It was too expensive, too complicated, too low a priority. Each time it fell through, a small but passionate group of planetary scientists pushed back. They organized letter-writing campaigns. They went to Congress. They refused to accept that Pluto would forever be known only as a fuzzy smudge in even the most powerful telescopes on Earth. And eventually, after more than a decade and a half of fighting, they won. New Horizons launched from Cape Canaveral, Florida, on January 19, 2006, aboard an Atlas V rocket. It was, at that moment, the fastest spacecraft ever launched from Earth, departing at nearly 58,500 kilometers per hour. To put that in perspective, at that speed, you could travel from New York to Los Angeles in about 3 minutes. And yet, even at that extraordinary velocity, Pluto was so far away that it took the spacecraft more than 9 years to reach it. 9 years of traveling through the void, mostly in hibernation to preserve its systems, watched over by a small and dedicated team who knew they were chasing something that had never been seen up close. When New Horizons finally swept past Pluto on July 14, 2015, it came within roughly 12,500 kilometers of the surface, close enough to see individual mountains, individual valleys, individual geological features that no human eye had ever resolved before. What it found there shook the scientific community to its core, not because Pluto was dangerous or strange in the way science fiction imagines alien worlds to be, but because it was so unexpectedly alive. Before the flyby, most scientists expected a dead, frozen, cratered wasteland, a relic world simply sitting still at the outer edge of the solar system, unchanged for billions of years. What New Horizons actually found was something so different that even the most optimistic members of the mission team were caught off guard. The mission unveiled a Pluto full of surprises, jagged mountains and deep valleys, sweeping dunes, hints of ice volcanoes, the largest glacier in the solar system, and evidence of a possible underground ocean of liquid water. For a world smaller than our own moon, this was almost incomprehensible. Pluto had no business being this dynamic, and yet there it was. The heart is probably where most people start when they think about Pluto's images, and for good reason. Tombaugh Regio, the pale heart-shaped region visible across Pluto's equatorial zone, was the first feature that truly captured the public's imagination when the images came through. The left side of that heart, a region scientists call Sputnik Planitia, is one of the most geologically remarkable surfaces in the entire solar system. It is a vast frozen nitrogen sea, smooth as a freshly resurfaced skating rink on a cosmic scale, stretching more than 1,000 kilometers across. The surface of Sputnik Planitia shows a polygonal convection cell structure visible over much of the plain. No craters have been found within it, indicating its surface must be less than 10 million years old, a blink of an eye in geological terms for a world that is 4.5 billion years old. Something is actively renewing that surface. Something beneath the ice is churning it, refreshing it, erasing any scars left by incoming debris. On a world billions of miles from the sun, at temperatures hovering around negative 230 degrees Celsius, this is profoundly unexpected. The mountains of Pluto are no less extraordinary. Ranges of jagged peaks rise as high as 3 kilometers, and the remarkable thing is that these mountains are not made of rock. They are built from solid water ice. On Pluto, water ice is the bedrock, the geological foundation of the world, rigid and strong at those extreme temperatures, the same way granite is rigid and strong on Earth. And sitting atop those icy mountain peaks, in a reversal of everything we understand from Earth's own atmosphere, there are snowcaps, not made of water, but of methane. Pluto's atmosphere has more gaseous methane at its warmer, higher altitudes, allowing that gas to saturate and freeze directly onto mountain peaks, tall enough to reach the enriched zone. The atmospheric temperature on Pluto actually increases with altitude, the opposite of what happens on Earth. And that inversion is what drives this bizarre snowing process. Mountains capped in methane frost, on a world where water forms the bedrock. It sounds like something from the imagination of a science fiction writer, but it is simply how Pluto works. Then there's the question of what lies beneath the surface, a question that has only grown more intriguing with every passing year of analysis. The shape and position of Sputnik Planitia itself has led scientists to a striking hypothesis. The basin is so massive and its weight is distributed in such a precise way relative to Pluto's axis of rotation that many researchers believe there must be a liquid ocean hidden beneath the ice shell, a deep reservoir of liquid water insulated by rock and ice from the absolute cold of space, possibly kept warm by a combination of ancient radioactive decay and internal pressure. Cryovolcanism, along with the reorientation of Sputnik Planitia, implies the existence of a subsurface ocean on Pluto and has placed this body among the solar system's potential ocean worlds, bodies that have reservoirs of liquid water under their icy crusts, making them candidates for presenting the fundamental conditions for fostering life. That last sentence deserves a moment of quiet consideration. We are talking about Pluto, the world that was demoted from planethood, the frozen rock at the edge of everything, potentially being discussed in the same breath as Europa or Enceladus when it comes to the possibility of life, and the ice volcanoes. Wright Mons and Piccard Mons are two enormous dome-like structures on Pluto's surface, each potentially hundreds of kilometers across and several kilometers tall. They are candidate cryovolcanoes, structures that may have erupted, not magma, but slushy mixtures of water, ammonia, and methane, oozing and flowing across the landscape in geological deep time. Evidence of ammonia-rich materials at sites on Pluto's surface has been found in the spectral data from New Horizons, and ammonia is a significant indicator of relatively recent cryovolcanic activity, because it would break down quickly under the bombardment of radiation unless it had been deposited in the geologically recent past. Whether these structures are truly active or merely ancient remnants of a more volcanically busy era is still debated, but the fact that the conversation exists at all speaks to how radically Pluto overturned scientific expectations. All of this was discovered from a single flyby, a spacecraft traveling at roughly 49,000 kilometers per hour, passing Pluto in the space of a few hours. Its cameras and instruments capturing everything they could before the dwarf planet receded into the distance. The closest approach lasted only a brief window. Then, New Horizons was passed, looking back at a crescent Pluto backlit by a distant sun, the atmosphere glowing blue with layers of photochemical haze, a deep, rich blue above a reddish-gold surface, a combination that almost nobody had predicted, and that nobody who has seen the image can easily forget. It took more than 15 months for the spacecraft to send all of its 6.25 gigabytes of photos and data home, because the spacecraft was roughly 4.5 light hours from Earth and could only transmit 1 to 2 kilobits per second. Every pixel of those images was hard-won across the vast distances of the outer solar system, arriving in fragments over more than a year of patient waiting. Then New Horizons kept going. Because the laws of orbital mechanics dictated its path, because the fuel budget allowed for a modest course correction after Pluto, and because a group of astronomers scanning the sky with a Hubble Space Telescope in 2014 found a small, faint target sitting almost exactly along the spacecraft's projected trajectory, there was a second act. The target was a Kuiper Belt object, an ancient, primitive body orbiting in the frigid outer reaches of the solar system beyond Neptune's orbit. It was given the nickname Ultima Thule, and later officially named Arrokoth, a word meaning sky in the Powhatan Algonquin language of the indigenous peoples of the Chesapeake Bay region of North America. On January 1st, 2019, New Horizons flew past Arrokoth. New Horizons came to within just 3,500 kilometers of the surface, making it the most distant target in history ever explored up close. What it found there was something that looked, at first glance, almost comically simple compared to the drama of Pluto. Arrokoth resembles, in the most technical of descriptions, a snowman. 2 rounded lobes, one larger and one smaller, gently pressed together at what scientists call the neck, the narrow constriction where the 2 bodies are joined. End to end, the overall shape of Arrokoth measures about 35 kilometers long, about 20 kilometers wide, and roughly 10 kilometers thick. By cosmic standards, it is a tiny thing. You could fit it comfortably within the boundaries of a mid-sized city, and yet Arrokoth may be one of the most scientifically important objects a spacecraft has ever visited. The reason comes down to what Arrokoth actually is: a fossil. Not a fossil in the biological sense, but in the deeper and more fundamental sense of the word. Arrokoth is a preserved relic of the conditions that existed in the young solar system more than 4 billion years ago, When the sun was newly born and the planets had not yet fully formed, when the disk of gas and dust and ice surrounding our star was still in the process of clumping together under its own gravity to build the worlds we know today. The objects that eventually became the planets started as smaller bodies called planetesimals, the true building blocks of planets, and for decades, scientists had argued fiercely about exactly how those building blocks came together. Was it through violent, high-speed collisions over long timescales, objects smashing into each other again and again until they grew large enough to dominate their neighborhoods? Or was it something gentler, a kind of gravitational choreography, where clouds of material collapsed inward on themselves and coalesced slowly, like a gentle gathering, rather than a demolition derby? Arrokoth answered that question definitively. The uniform color and composition of Arrokoth's surface shows the Kuiper Belt object formed from a small, uniform cloud of material in the solar nebula, rather than a mishmash of matter from more separated parts of the nebula, supporting the idea that Arrokoth formed in a local collapse of a cloud in the solar nebula. If violent high-speed impacts had been responsible for building Arrokoth, the two lobes would show signs of dramatic deformation, fractures, compositional differences, the scars of catastrophic mergers. Instead, the surface is smooth and uniform in color, a muted reddish hue from top to bottom on both lobes. The two bodies that joined to form Arrokoth appear to have drifted together in a slow, gentle spiral, drawn by their mutual gravity into a tender contact binary, colliding at very low speeds, more like how you might walk into a wall as opposed to supersonic impacts. As principal investigator Alan Stern put it, Arrokoth may have been even more important scientifically than Pluto. It settled a decades-long debate about how planets are born. Arrokoth's geology supports the streaming instability model of planetesimal formation, where collision speeds of just a few miles per hour allowed objects to gently accumulate to build Arrokoth in a local area of the solar nebula undergoing gravitational collapse. This model, called the streaming instability or particle cloud collapse model, has now become significantly strengthened by what Arrokoth revealed. And the implications extend beyond just one small object at the edge of our solar system. If this is how the building blocks of our planets formed, then it changes our understanding of how planetary systems throughout the entire galaxy come together. Every time we look at another star system and wonder whether it might harbor worlds, the lessons of Arrokoth are part of what informs that question. Even more recent analysis has found something additional and strange in Arrokoth's structure. The surface contains large mound-like features, whose sizes and properties appear strikingly similar to each other, hinting at a common origin in the formation process. Researchers presented findings at a 2023 meeting of the Division for Planetary Sciences, suggesting these similarities reveal new insights into how Arrokoth was built from its original cloud of material. And in early 2024, a separate study explored whether Arrokoth might still harbor ancient ices deep within its interior, preserved volatiles from the very beginning of the solar system, sealed inside its porous, fluffy bulk. Researchers found that the double-lobed object may have ancient ices stored deep within it from when the object first formed, potentially locked away from any warming or processing by the sun for over 4 billion years. To hold something so ancient and so chemically pristine is extraordinary. Arrokoth is not just a relic of the early solar system. It may be a time capsule containing the actual chemical ingredients from which our world and every other planet was built. Now zoom out. Let that sink in for a moment. In the span of a single mission, a spacecraft about the size of a grand piano, running on less electrical power than a pair of household light bulbs, traveling at nearly 50,000 kilometers per hour, humanity obtained the only close-up views it has of a potentially ocean-bearing world with active cryovolcanoes and nitrogen glaciers, and the only close-up views it has of a pristine 4-billion-year-old fossil from the dawn of the solar system. Both of those firsts happened on the same spacecraft, on the same journey outward from the sun, separated by less than 4 years of travel. It is one of the most extraordinary scientific doubleheaders in history, and here is what makes those images so irreplaceable, so precious, in a way that can be hard to fully articulate. New Horizons is the only spacecraft in the Kuiper Belt, and the only one currently planned to go there. There is no follow-up mission to Pluto in development, no orbiter, no lander, no second flyby. The James Webb Space Telescope has observed Pluto from afar, adding to our understanding of its surface composition and its faint atmosphere. But Webb operates at enormous distances from Pluto and cannot resolve the surface features that New Horizons revealed. The Hubble Space Telescope, before New Horizons arrived, showed Pluto only as a blurry handful of pixels. That is what awaits us again. The best views that modern ground and space-based telescopes can produce of Pluto fall infinitely short of the images taken from 12,500 kilometers away in the summer of 2015. Those images, the heart, the mountains, the blue haze, the crescent glow, are likely to stand as humanity's best views of Pluto not just for years, but for generations. New Horizons is currently traveling at about 49,200 kilometers per hour and covering around 480 million kilometers every year. Its mission will continue until it exits the Kuiper Belt in 2028 or 2029, at which point NASA may decide to shut down the mission. The spacecraft's plutonium fuel generator could keep it operational into the 2040s, by which time the probe will be around 15 billion kilometers from the Sun. The mission team has been searching for a third Kuiper Belt object close enough to the spacecraft's trajectory to enable another flyby, scanning the sky with the Subaru telescope in Hawaii for a suitable candidate. As of June 2024, no suitable targets have been found. The window for such a discovery is narrowing with every passing month, as New Horizons pushes deeper into the outer belt, and the geometry of any possible diversion becomes increasingly impractical. The mission has not been without its struggles on Earth either. In 2025, the White House's proposed NASA budget would shut down New Horizons mid-flight, and the mission's future has been actively debated in the United States Congress. The cost to keep New Horizons running is modest by any government standard, roughly $10 million per year. But in an environment of deep budget pressure, even that modest figure has been the subject of intense debate. The scientific community has pushed back forcefully. You do not build a nearly $1 billion spacecraft, send it on a 9-year journey, have it rewrite what we know about the outer solar system, and then switch it off while it is still healthy and transmitting data from a region of space that no other human instrument can reach. The argument is not only scientific, it is civilizational. We are the only species in the known universe that has ever built something and sent it to another world to look. The decision about whether to keep looking or to stop says something about who we are. Think about what it means that these images exist at all. Pluto was discovered in 1930 by a young astronomer named Clyde Tombaugh, working at the Lowell Observatory in Arizona. For 85 years after that discovery, Pluto was nothing more than a point of light. Not a world, not a place with mountains and glaciers and moons and seasons and an atmosphere that glows blue, just a point, a dot in a photograph, barely distinguishable from the background stars, moving slightly from one night to the next. An entire world, sitting at the outer edge of our solar system, invisible to us in any meaningful sense for most of a century. New Horizons actually carries 30 grams of Clyde Tombaugh's ashes on board, a tribute to the man who first spotted that point of light. His remains are now the farthest from Earth of any human material in history, sailing through a darkness he never lived to see, past the world he spent his life discovering. What the images show us is not just Pluto, they show us the Kuiper Belt itself, a vast ring of icy worlds orbiting the Sun beyond Neptune, containing hundreds of thousands of objects, perhaps more, each of them potentially as complex and surprising as Pluto. In September 2024, the New Horizons team detected evidence of an unexpected population of Kuiper Belt objects, and observations from the Subaru telescope suggest the Kuiper Belt may extend significantly further than previously theorized. There may even be a second, more distant belt of similar objects beyond the one we currently know. Each of those worlds is a time capsule. Each is a chapter of our solar system's biography, written in ice and rock in ancient chemistry. And we have visited exactly 2 of them up close. 2 out of potentially hundreds of thousands. The images of Arrokoth haunt in a different way than the images of Pluto. Pluto is dramatic. It demands your attention. Arrokoth is quiet. It hangs in the blackness, small and reddish, its 2 lobes gently touching like an embrace frozen in time for 4 billion years. It does not look extraordinary at first glance, but knowing what it represents changes everything. Knowing that it was assembled grain by grain in the original dust cloud that surrounded the young sun, that its 2 lobes slowly spiraled together under their own tiny gravity over millions of years, that it has sat out there in the deep cold, largely unchanged since before the Earth existed. Knowing all of that transforms the image. Arrokoth is a window, not into alien strangeness, but into our own origins. The material that built Arrokoth is the same kind of material that eventually, through collision and accumulation in time, became the Earth, became the oceans, became the chemistry from which life arose. There is no return scheduled. No human hands will touch the soil of Pluto in any of our lifetimes, and probably not in the lifetimes of our grandchildren. As New Horizons principal investigator Alan Stern has stated, we are the only spacecraft out there. There is nothing else planned to come this way, and so the photographs remain what they are, a brief, extraordinary opening of a window that has since been closed again. A few hours in July 2015 and a few hours on the first day of 2019, when a small machine sent by a civilization on a small world around an ordinary star looked closely at 2 ancient frozen places no one had ever seen and found them far stranger and far more beautiful than anyone had dared to imagine. That heart on Pluto's surface, Tombaugh Regio, was named for the man who spent his life staring at photographs of the sky, searching for something he could not yet see. He found it. And then, 85 years later, we finally truly looked at it. The last clear image we may ever have of that heart is the one that already exists, frozen in the cameras of a spacecraft that has now traveled twice as far from the sun as Pluto itself, carrying a handful of dust that was once a man, sailing outward into a darkness that goes on forever. The question it leaves behind is a quiet one, but it never stops echoing. Given how much we found in just 2 brief glances, and given how much of the Kuiper Belt remains unseen, what else is waiting out there that we have not yet thought to look at?